So in the previous video we actually solved this problem, the problem of gradual cutoff. Okay, uh, we can solve this one by using higher order filters like second order or third order filters. So in that case, the slope in the first order filter we had 20 decibel per decade, but when you are actually adding more reactive components, it actually multiplied by n. So now we have, for n equals to 2 second order filter, I have 40 decibel per decade. That means per decade it is actually decaying by 40 decibels. So I have a more straight slope. Okay, I have a far more straight slope. For normal scenario it was like this. Now I have like this, I have like much more straight slope. Okay, but that was a good thing, that solves my problem. But it creates an additional problem, that the gain, okay, the gain decreases, okay, at this rate. Okay, the gain decreases at this rate. That was my this problem, attenuation of my original signal, and how we can deal with that, how we can solve this problem, and that is what we are going to discuss. Now before we actually go there, there are some other things that you need to know actually. Let's move this portion. Okay, now so far the filters that we used, we have designed, we have all used only R and C. Okay, so a resistor and a capacitor. Now these are what we call passive elements. Okay, I think you should know these things. Passive elements. Okay, these are what we call passive elements. Now there are some other elements that we call active elements. Now what is a passive element? So a passive element is something that does not require any source to operate. For example, if you connect a resistor, it will automatically operate if you connect a resistor in a circuit. But say if I want to add an op-amp, okay, if I want to add an op-amp to the network, you have to power up the op-amp by using a DC voltage source, if you remember. Or say if you use an SCR, okay, SCR, silicon control rectifier, you also need a power source to operate those things. So these are what we call active element. These are what we call active. Okay, and these are what we call passive elements. Passive elements like R, L, C. These three. Okay. Now, so the previous filter that we designed using RC network, it's a simple passive filter. So we call it a passive filter. Okay, now but now when we actually dealing with this problem, that is my attenuation of the input signal, I need to use some active element. Now why is that? As you can see in the passive filters, we don't have any amplifying element. Okay, we don't have any amplifying element. That, for example, op-amp actually increase my input voltage. If I have like 10 volt and I have a gain from op-amp like 10, then it will make my input signal like 100 volt. Okay, but RLC, these are passive elements, they cannot actually boost my signal. So when I have in the here, when I have designed a passive filter from this one, my output, so the input signal has actually attenuated from 1 volt. Say from 1 volt it becomes 0.5 volt. Now if we actually add from this portion an op-amp, okay, that op-amp can actually boost my signal, so I can increase my input value of the voltage by using an op-amp. So then what we are actually doing, I am actually converting my passive filter into an active filter. So now I want to design okay. So now I want to design an active filter using an op-amp. Okay, so let's do this with in here. So first let's do something, is that crop this portion out. Now let's make a new one. Okay, try to build a new one, but keep this portion, just copy this portion so that I can use, and keep this one and try to build a new one, new project again. Let's name it LPF2. Okay, LPF2 blank project. Okay, so now I have this one. Let's do something, is that I want it close. Okay, because I need to place a lot of things here. So I am first creating a low pass filter. Okay, a low pass filter which is a passive filter. Okay, this is my low pass passive filter, R1, R2. Okay, and this is my original. Let's change these values to 0.01. Okay, now I want to connect an op-amp. So go to the sources, LM741. Okay, you have this LM741 here. I think I should put it much further. Now I want to use an inverting non-inverting amplifier. Okay, I want to use my op-amp solely for the amplification purpose. My input signal, the output signal that I was actually getting from the output signal that I was getting from here, that was actually attenuating. So I want to amplify that signal using a non-inverting amplifier. Okay, so I have placed my op-amp here. Then I connect my input, okay, to the positive side. Connect my input to the positive side, and I will take the output from here. Okay. Now there are some additional components that I need. So first of all, I need to place two voltage source here. One is here, another one here. Okay, now this is my positive source, and this there goes to my negative one. Okay, I need to place to ground here. Ground. So since I am connecting this voltage source, that is why we call it an active element. Okay, let's make it 15 volt. Okay, also make it 15 volt. So make it 15 volt. Okay, now I have to provide here with my feedback. Okay, this is my feedback resistor. Okay, let's place some resistor. This is my one resistor. This is my second one resistor. This is my second resistor. Okay, one, two goes here, another resistor. No, I think it is enough. So I connect my resistors. Remember your inverting amplifier connection. Okay, this one goes to ground. Okay, this one my left side, this one goes to ground, and this one goes to my feedback resistor. This one is connected to my output terminal. Okay, so this is my circuit. Okay, now I have to run it. Okay, I have already, here you can see new simulation. Make it LPF2, create. I have already created one. Let's make it LPF3. There I have to go to AC sweep. Start frequency is 1, and the in frequency make it larger. Okay, make it 0 0 0 0. Make it 10. Apply and okay. Now I have not pressed any probe. This is my input. This is my output from my passive filter. This is my output from active filter. Okay, yeah, I think everything is okay now. So let's try to run it, see how to actually get, how do you get. So this is my output. Okay, here you can see the blue one is my actual output from my active output. Okay, so this blue one. This was my original signal. This red one is the output from my passive filter, and this green one or violet, whatever, and this is what, and this blue one, this is what is my output from my op-amp. Okay, so it has actually multiplied. My original signal was 1 volt, now it is 2 volt. And why is that? You know that, if you remember the equation, you will understand. So let's write it down here. From a non-inverting amplifier, so when I am actually creating a non-inverting amplifier, right? Non-inverting amplifier. So the output of a non-inverting amplifier is 1 plus Ri divided by Rf, right? The input resistance and output resistance. Now if we actually look at it here in the circuit, this was my Ri and this was my Rf. I made the voltage, made the resistance value same, so I had 1. So 1 plus 1, so 1 plus 1 is actually 2. That's why I am getting the double output here. That's why I am getting double. So if you actually change it, let's change it. 1 plus Rf by Ri. I made a little mistake here. That should be opposite. Okay. So let's make it 3K. Okay. So let's run it again. So now see, it has actually 4 times, because 1 plus 3, that is 4 times. Here I made a little mistake here. It should be Rf by Ri. That is my feedback resistor divided by my input resistor. Rf by Ri. Okay. So that is my output. So when I have, so let's actually make it together. I had a passive filter first, and I have a second order passive filter. Okay, the problem was I have some attenuation of the signal. I have this problem, attenuation of my input signal. To solve this, I have converted my passive filter into an active filter by connecting an op-amp. Okay, I am using my op-amp as a non-inverting amplifier, which will give my amplification by this range, 1 plus Rf by Ri. So by choosing this value, I can actually select how much amplification do I want. Okay, there are some other issues that I am going to show you in the next video of this one. Okay, so at least we actually now understand how we can actually deal with these two issues, the issues that we actually get with the passive filter. And this is my design of active filters. Okay, I hope it's okay. Well, one other thing to notice here is that you can see here, when we designed an active filter, my cutoff frequency has not changed. Remember, my cutoff frequency value depends on the resistor and the capacitor that we used. The resistor and capacitor that we used here. Okay, the cutoff frequency is not changed by adding an op-amp to my network. Okay, only my input signal amplitude has increased. Okay, it has amplified. Okay, I think it's okay.